Hi everyone, welcome to my channel Chemistry Tutorials by Kiranmai. Today in this video I am discussing about energies of orbitals. In earlier video we discussed about shapes of atomic orbitals. In this video we are discussing about energies of orbitals. In hydrogen atom, the energy of an electron is determined by principal quantum number. So energy of an orbital is as the principal quantum number increases, energy of the orbitals increases. For example, 1s is less than 2s 2p, which is less than 3s 3p orbitals, 3d orbital, which is further less than 4s 4p 4d orbitals, and so on. So as the principal quantum number increases, the energy of the orbital decreases. So if we take a line showing that the increase in energy, 1s orbital will have least energy when compared to 2s 2p orbitals, and then which have least energy when compared to 3s 3p 3d orbital, which is less than 4s 4p 4d orbital. So these orbitals will have different energies depending upon the principal quantum number. Though 2s orbital and 2p orbitals have the same principal quantum number, in hydrogen atom they also have the same energy. See here, s orbital, p orbitals will have different shapes, but it have same principal quantum number. In this they have same energy. So the orbitals with same energy, irrespective of the shapes of the orbitals, if they have the same energy, then these orbitals are called degenerate orbitals. Degenerate orbitals. And in hydrogen atom, if the electron is present in one s orbital, it is considered to be the most stable condition, and the state is referred to as ground state. Ground state, which is most stable state, and the electron will have low energy. Why? Because these electrons are strongly attracted by the nucleus. So as the nucleus charge will effectively attract the electron, the lowest energy level will be most stable, and it is considered to be as a ground state. When we compare to the higher energy levels, that is 2s to 3s 4s orbitals, these orbitals have comparatively higher energy than 1s orbital, and they are considered to be excited state. And then when we come to multi-electron system, so in multi-electron system, energy of orbitals is determined by principal quantum number and also azimuthal quantum number. For a given principal quantum number, means principal quantum number mainly tells about the shell, means 1, 2, 3, 4 shell, 3 shell, 2 shell, 1 shell. But azimuthal quantum number L, principal quantum number N, azimuthal quantum number L tells us about subshell. So for given principal quantum number, for suppose for 4s 4p 4d, 4f orbitals, means 4 shell orbitals. If we consider these orbitals, then the subshells will have different energies. S, P, D, F. S orbital will have lower energy than P orbital. P orbital will have lower energy than D orbital. D orbital will have lower energy when compared to F orbitals. So this is particular only for one shell. When it gets mixed up, means 3 shell, 2 shell and 1 shell is also present in the atom. If we consider all shells, then it will be like this: 1s orbital, which is lower than 2s, lower than 2p, lower than 3s, lower than 3p, lower than 4s, lower than 3d. Individually, if we consider 3 shell orbitals, then 3s orbital is lower than 3p, 3p orbital is lower than 4d. But as seen in hydrogen atom 3d, these 3 shell is lower than 4 shell. But here in multi-electron system, it is not like that. It got mixed up. See here, we can't see that 4s shell is having the higher energy than 3d shell as seen in hydrogen atom. This is because of mainly electronic interactions. See, in atom we can observe 2 types of electronic interactions. There are attractions and there are also repulsions. Attraction means the attractive force between positively charged nucleus and negatively charged electrons. These are attracted with each other, and the repulsions or the force of repulsions between one negatively charged electron with its surrounding negatively charged electrons. So attractions between positively charged nucleus and negatively charged electrons, and repulsions between one negatively charged electron and surrounding negatively charged electrons. As the charges are same, they get repelled, and as the charges are opposite, they always tend to attract. Due to these type of electronic interactions, we can see that splitting of energy levels. Let's see in brief. In hydrogen atom, how many electrons are there? Yes, only 1 electron. So, as there is only 1 electron, we can see that only attractions can be seen in hydrogen atom. See, attraction between this 1 electron and nucleus. Attraction. There is no other electron to repel. So in hydrogen atom, there is no repulsions. No repulsions. Due to this, as they have no repulsions, when one shell is considered as 2 orbitals, 2s, 2p orbitals will have only 1 electron. So there is no repulsion. So there is no splitting of these 2s and 2p orbitals. But whereas in multi-electron system, we can observe both attractions and repulsions. attraction between nucleus and electron, and repulsion between electron and its surrounding electrons. So due to these repulsions, the energy levels get split. Okay. Before heading into the topic, let's have a brief note on the shielding effect and effective nuclear charge. We all know that the electrons which are present in the outer subshell and the electrons which are present in the inner subshells are different with each other. See, difference means the type of nuclear charge facing or experiencing on the inner electrons is different when compared to the nuclear charge experienced by the electron when it is present in the outer subshell. These electrons cannot access or cannot feel the complete nuclear charge given by the nucleus as the inner electrons shield it. This can be explained with an example. Consider a magnet. If you place an iron nail at a distance and see that the attraction force, and if you place some iron nails in between and see the attraction force, there will be a slight difference. Here the attraction force will be more stronger when compared to this one. Why? Because the underlying or these iron nails will reduce this magnetic power over this nail. In the similar way, this nuclear charge or this nuclear attractions which are coming from the nucleus can be reduced by the presence of the electrons here in the inner shell over the outer shell electrons. If we consider the same principal quantum number for shell, and we are considering s, p, d, f orbitals, s orbital will have circular shape, and then p orbitals will have dumbbell shape. If we are comparing s orbital and p orbital, the electrons present in s orbital can effectively shield more when compared to electron present in p orbital. Similarly, the electrons present in d orbitals are capable of shielding very well when compared to f orbital. Due to these shielding effect, the nuclear charge over the outermost electron, means the net nuclear charge experienced by the electron, effective nuclear charge, effective nuclear charge means the net positive charge experienced by the outermost electron will get decreased. Due to this, s orbital will have lower energy when compared to p orbital. P orbital will have lower energy than d orbital. D orbital will have lower energy than f orbital. To know the energy of different orbitals, means whether it is present or having the lower energy or whether it is present in the higher energy orbital, to know these things or to compare things, we have a rule. By this rule, we can determine, using principal quantum number and asymptotal quantum number, we can determine whether it has a lower energy or higher energy. In this, first point is n plus L value. Calculate n plus L value for the given two orbitals and then compare n plus L value. If it has lower n plus L value, then it is considered to be lower energy orbital. In case if you have same n plus L value, then consider n value. Lower n value orbital will have lower energy. Let me explain this one with example. For example, 4s orbital and 3d orbital. For these two orbitals, we want to check which one is the lower energy level and which one is the higher energy orbital. First step is to calculate n plus L value. N means principal quantum number, L means asymptotal quantum number. For s orbital, asymptotal quantum number L is 0. For p orbital it is 1, d orbital 2, f orbital it is 3. So for 4s orbital, n plus L value, n means 4 and L means for s will have 0. So 4 plus 0, 4. For 3d orbitals, n plus L value. For 3d orbital, principal quantum number is 3, asymptotal quantum number d. For d it is 2. So 3 plus 2, 5. So 4, 5, which have lower n plus 1 value will be lower energy orbital. So here 4s orbital is lower energy than 3d orbital. So 4s will have less energy than 3d orbital. Let us consider the other example, 3s and 2p orbitals. 3s and 2p orbitals. For 3s orbitals, if you calculate n plus L value, principal quantum number 3 plus asymptotal quantum number s value is 0. So 3 plus 0, 3. For 2p orbital, n plus L calculations. So principal quantum number n is 2 plus asymptotal quantum number L is 1. So we have the same n plus n value, n plus L value. So we have to consider lower n value. So lower n is 2p. So lower n value. So 2p will have less energy when compared to 3s orbital. So by using this rule, we can calculate the orbital which have lower energy and higher energy. And it is important that this rule is applicable only for multi-electron system. And for hydrogen atom, it is 1s greater than 2s 2p, which is greater than 3s 3p, which is greater than 4s 4p 4d 4f orbital. And another important note is, if we consider one subshell, for suppose 2s subshell in different elements, suppose lithium and helium. So as these 2s orbital present in lithium and 2s orbital present in helium will have different energies. The energies of the orbitals in the same subshell decreases with increase of atomic number. That means energy of 2s orbital in lithium will have less energy or lower energy than 2s orbital of helium. This is because as the atomic number increases, so when compared to helium, lithium atomic number is more. So as the atomic number increases, it attracts more. So 2s orbital will move towards the nucleus, so it will have less energy. So this is today's topic, energies of orbitals. Hope you understood this one. If you have any doubts, ping me. If you understand my lesson, like the video, and share with your friends. Thank you.